All right. So, Dr. Lanotte with Michigan State University will be moderating this session for us. I just want to give a reminder to our speakers and moderators who are on this session to go ahead and mute your microphones and turn off your cameras if you are not speaking. With that said, Dr. Lanotte, the stage is yours, and we're looking forward to this session.
Thanks, Stephanie. Hi, everybody. I hope you're enjoying the session so far. Right now, we have the graduate student research presentations. We have 6 amazing presentations from our students. There will be not a lot of time for each one of you. Unfortunately, we have a pretty busy session here. We have 6 presentations in 1 hour. So I would like to remind all the presenters that they have around 7-8 minutes maximum so that we can have some questions at the end of their presentation. The first presenter is Kalani Rajamanthri. I hope I pronounced your name correctly. Kalani, while you put your presentation on share screen, I introduce you briefly. Kalani is a PhD student in geotechnical engineering at Arizona State University. She's from Sri Lanka, and she has professional experience as a geotechnical engineer, and her research focus on unsaturated soils, geosynthetics in road construction, and slope stability. Kalani, floor's yours.
I need help to share my screen from the admin.
Okay.
Need to yeah.
Stephanie, you may want to jump in here.
Okay.
All right.
Yeah.
Thank you.
Yeah. Hi all. So I'm Kalani Rajamanthri. I'm from Arizona State University. So today I'm going to present some of the key findings of my research. So my topic is variation of soil shear strength with moisture content, a comparative study of soil and soil geosynthetic interface. So I'm doing this research under the guidance of the Associate Professor Claudia Zapata. Next slide, please. So here's a quick outline for my today's presentation. I'll start with an introduction and followed by the problem description, objectives, and then I'll go through the methodology, key results, and the current work in progress. So finally, I'll open it up for any questions. Next slide, please. So first of all, let's cover some of the background concept for my research. So first, slope stability and soil strength are considered as some of the essential factors for embankment stability. So they are mainly depends on the shear strength of the underlying soil. So in construction, we often work with the soil that are unsaturated. So they have like negative water pressure or suction, which play a big role in the stability. So the next thing is the shear strength. Shear strength is also a critical factor, especially in the presence of the water infiltration. So we consider both saturated soil and unsaturated soil to see how the shear strength varies with respect to the different moisture conditions. So if we have to deal with some of the problematic soils like expansive clays and frost susceptible silty soils, it's going to be kind of challenging because they are very sensitive for the moisture fluctuation together with the external stress variations. So to help stabilize these kind of soil slope, geosynthetic can be an effective approach. So geosynthetics are effective in strengthening the soil and enhancing the drainage. So especially when the soil replacement or improvement is not a cost-effective approach. Next slide, please. So this slide highlights the problem and the objectives of my studies. So the geosynthetics are widely used to improve the soil stability, and performance are often measured or evaluated using the pull-out test results. So as I mentioned earlier, that the true slope stability analysis require a deeper understanding of the shear strength properties. So that may not fully capture from the pull-out test results. So the problematic soil often require expensive solutions like chemical stabilization or the costly removal or replacement practices. So there's a need for a more effective approach to improve the soil stability. So my study aims to understand how moisture content varies with the shear strength properties and how it will vary with and without geosynthetics. Next slide, please. So this is the methodology for my research. So this study involves laboratory testing to assess both shear strength properties and the unsaturated hydraulic properties. On the left, we tested two types of soil samples, like regular soil and the soil that are reinforced with the Bhuiyan geotextile. So we conducted normal direct shear testing for the regular soil and large direct shear testing for the reinforced soil. So tests were performed at various degree of saturation, varying from 30% to like 100%, under like different normal stresses, varying from 20, 40, and 80 kilopascal. On the right side, we measure the hydraulic unsaturated hydraulic properties using the Fredlin device to obtain the soil water characteristic curve. So together with these, the shear strength properties and the unsaturated hydraulic properties, we try to give a clear picture of how shear strength properties varies with and without geosynthetics under different moisture conditions. Next slide, please. So under the results and discussion, first let's see about the soil water characteristic curve. So soil water characteristic curve shows how soil retains the moisture at different suction levels or different negative water pressure levels. So samples were compacted to like 95% relative compaction, and we use an oedometer type device like Fredlin device to gather the data and fitting it to the Fredlin and Sin equation. So a key finding here in the SWCC the curve is the air entry value, which is around like 1.7 kilopascal. So which defines the air entry point in the soil sample. So beyond this point, as soil dries, the suction or the negative water pressure will increase to up to like 30,000 kilopascal. So here after the 1400 kilopascal for up to like 13,000 kilopascal, I try to derive it using the extended drying curve using the Fredlin and Sin equation. Next slide, please. So the next result is the shear strength properties using the normal direct shear test. So here this graph shows the shear stress versus normal stress across different degree of saturation levels. So we can see that it reveals kind of a nonlinear trend. So at fully saturation condition, the shear strength is lower due to the absence of the metric suction or the negative water pressure. So as saturation decreases, the metric suction increases, which results in having an apparent cohesion, and it leads to have a higher shear strength. So however, at very low degree of saturation, like 30%, which shown in like in orange color, the soil become more brittle and it reduces the shear strength under high normal stresses. So this table highlights how cohesion and friction change with the suction values. So in this case, I just present only the degree of saturation for 100%, like it have a cohesion of 16 and the angle of internal friction about 43 degrees. So when the sample gets unsaturated, like we need to consider about the suction properties. So we are still working on that. So we will present this in future. Next slide, please. So this slide here, we like further explore the relationship between the shear stress and the metric suction under different normal stresses. So in the left graph, we can see a nonlinear behavior of shear stress and the metric suction. So when the metric suction increases beyond the air entry value of 1.7 kilopascal, the behavior is going to be nonlinear. So at low suction rate, the angle of the phi b, which is the contribution due to the suction, is similar to the effective friction angle like phi prime. But as suction goes beyond the air entry value, so the phi b decreases and eventually stabilizes at high suction levels. So the right side graph shows the shear stress at higher suction levels for different normal stresses. So at these high suction levels, the soil structure becomes more rigid, which limits the effects of the phi b on the shear strength. So the next slide, please. So this is the last result. So this compares the shear strength with and without the Bhuiyan geotextile at optimum moisture conditions. So this graph shows that the regular soil has a higher shear strength compared to the reinforced that soil geosynthetic reinforced soil, especially as normal stresses increases. So it indicates that the soil alone resists shear forces better. So this table highlights the regular soil has a cohesion of 35 kilopascal together with the internal friction angle of 50 degrees. And for the rainforest soil, it has a cohesion of 19 kilopascal and the internal friction angle is 34 degrees. So this reduction in the strength can be because of the less particle interlocking over the potential slippage, which limits the bonding between the soil and the geotextile. Next slide, please. So to sum up the presentation, like we found out that when the soil begins to desaturate, shear strength increase linearly up to the entry value, and after that it rises non-linearly and eventually levels off at the high suction levels. So in saturated soil, the shear strength is mainly controlled by the net normal stress. But if we have to consider the unsaturated soil, the shear strength is mainly controlled by both of the net normal stresses and the change in the suction. So we are conducting further testing to see how suction affects, like how suction affects the soil geosynthetic interface with different soil types, which will help us to have a better understanding of the rainforest soil behavior with the various moisture conditions. Next slide, please. So this is the current work in progress. So we are working on normal direct shear test on expansive clays to establish the unsaturated shear strength behavior with different normal stresses and varying the moisture condition. And we are working on the large direct shear test on how geotextiles and geocomposite materials will behave under like with the expansive soil and the frostive soil. And finally, we are on the process of having the higher suction range for soil water characteristic curve using the filter paper test and the WP4C device. Next slide, please. So these are the references that I use for my presentation, and that's it. Thank you so much for giving me this opportunity. If there's any question, I'm happy to answer for that.
Thanks, Kalani. Thanks for the very comprehensive presentation. I don't see any question in the Q&A box here. I kindly ask everybody who's attending this session to place your question in that chat box. Quick question for you, Kalani. I see I want to go more practical here. I've seen some very nice and fancy equations there. But from a practical perspective, what do you see is the impact of moisture variation in the shear strength of soil when you have an interface between soil and geotechnic instead of having soil only?
So I think like when we have to like treat the problematic soil, so most of the cases like in Texas or the Michigan state, they are having kind of variation of the moisture condition. So I think like so we need to like consider about this the I mean like if there's a good contact between the soil and the geosynthetic, so it will I hope to it I hope it will have good contribution to the soil because of the suction contribution and from the the reinforcement from this geosynthetic.
All right, thank you. Thank you so much. In the interest of time, if there is any other question, please write it down in the chat box or in the Q&A box on the top right corner of your screen. Thanks, Kalani. Thank you so
Yeah,
much.
welcome.
And we'll move forward to the next presenter here. Presenter is Qasim Zulfiqar. Qasim is a PhD student in civil engineering at Michigan State University. His PhD work focuses on the long-term performance of stabilized aggregate layers. Qasim, floor's yours. When you see my face popping up, it means that you have only 1 minute remaining. Thank you. And
Good.
please, everybody, close your cameras and microphones while the presenter is showing the slides. Thank you.
Got it, Dr. Mike. I would just like to say I don't see the share presentation.
It should be down.
Yeah,
Yes.
it is there, and I was just trying to. the window. Yeah, got it.
You got it?
Yeah.
Perfect. Go ahead.
Can you see my screen?
Yes, if you can put it in presentation mode, that
Uh,
would be
it,
helpful.
yeah, it is in the presentation mode.
No, we still see the PowerPoint
Okay.
instead, so you need to.
Okay.
Yes, Kasim, if you go ahead and stop sharing your screen real
Okay.
quick, and then go ahead and launch your presentation in presentation mode, and then now in Remo, go ahead and hit that share, and then select the screen.
Okay.
And that should work for you.
I guess it is still the presentation mode. Is it in the presentation mode right now?
No, we still see
Ah,
the PowerPoint. First, you put in presentation mode, and then you share it here
okay.
on Remo.
Okay, there is something wrong with this thing.
Just for the sake of time, I'm thinking if you just go
Yeah.
ahead and share your
Yeah,
presentation the way it
sure.
was
Thank you so much.
going, I
Thank you.
think that will be okay.
Yeah. I guess you can see the slides, right?
Yes.
Okay, thank you so much. Thank you. I'm really sorry. I apologize for this technical mistake. So, hello everyone.
Not yet, Kasim. We don't see the presentation, so you need to put it on share.
Okay. Here we go.
Yes, go ahead.
Yeah. Okay, everyone. Really sorry again for the technical mistake. So, hello everyone. My name is Qasim Zulfiqar. I am a first year PhD student from Michigan State University. I am working with Dr. Bora Chetan, and the research that we are focusing on is the long-term performance monitoring of the stabilized and cement-related granular layers in the pavement. I will just briefly touch upon the background. I will just discuss after that, I'll discuss the goal and research objectives. I will mention the test locations that we have been to, followed by the ongoing field and laboratory analysis. Okay, so coming to the background first, obviously application of the stabilizers and cement-related aggregates in granular layers is carried out due to certain reasons. Those reasons may be improving the load-bearing capacity of the pavement system, enhancing their durability, cost effectiveness, which is directly and indirectly related to the recycling of the materials as well. Now, across USA, what we have seen is the use of chemical additives, cement-related aggregates, and different mechanical methods in order to achieve the mentioned objectives. Now, these materials and these aggregates and these stabilizing agents are being used in the pavement network. What we have seen is that people carry out their long-term performance analysis using accelerated aging in the labs. Now,
Kasim, sorry
yes,
to interrupt,
yes, Dr.
but yes, now we see the background slide. We were looking at the initial slide, so make sure to select the slide.
Got it. Got it. So for the background slide, as I said, what people have previously done in order to assess the long-term performance of the aggregates or the stabilizing agents, what they have done is carried out the accelerated aging in the lab. Now we have an understanding where lab atmosphere, lab conditions cannot exactly replicate the conditions that we have in the field, and along with the long-term exposure of such stabilizers or such cement-related aggregates having different elements in them also also pose some environmental risks. So keeping that in mind, what we are doing here is we are trying to have the assessment of the long-term performance of these aggregates, such materials that were exposed to the extreme freezing and thawing cycles over the past 5 to 10 years. And we are also incorporating the environmental impact analysis while doing that. So our research started with locating the existing sites, the sites that have used such stabilizers. Those stabilizers may be chemical stabilizers, recycled concrete aggregates, steel slag, cement-related aggregates. And once we had located those sites, we are carrying out the forensic analysis to evaluate the geomechanical and the environmental long-term performance of these type of materials. And along with that, obviously, we are also looking at the micro and macro mechanical behaviors of these materials. And once we have that, we see that this is how they are mechanically behaving after a long-term exposure in the field. And this is the environmental analysis that we have. Combining these two, we are going to develop a new durability assessment framework for designing and screening of such stabilized soils and geomaterials to be used in the transportation. For the sites, we have different sites in Iowa, in Minnesota, and the type of aggregates that they have in those granular layers include cement-treated base and subgrade. Some of the sites have used different types of steel slags, chemically treated base and subgrade materials. Some of those sites have reclaimed asphalt pavement, wrap aggregate, and some of those sites obviously have the recycled concrete aggregate in them. So after locating the site, we have been in the field to carry out the field testing. Those testing includes the LWD, lightweight deflectometer testing, along with the DCP, dynamic cone penetrometer. We have done the nucleic gas density test, along with checking out the saturated of the in situ saturated permeability of the materials themselves. Now, keeping the time constraints in mind, I have just put the results of the LWD testing that we have there. As you can see, there is the variation in results of the recent two testing periods that we have. Along with that, we have also collected materials to carry out the lab testing, and that lab testing includes the resilient modulus test. We are also planning to carry out the permanent deformation test. And the one more test that we are planning to have is the heat of hydration test. Now, that heat of hydration test, as you can see, if you can follow my pointer here, this is the test setup that we have for the heat of hydration test. We are going to have a cement-related RCAs or steel slags in the box underneath, and try to provide a unidirectional supply of water in the form of this rain simulation from the top. Now, once we have the RCAs or the cement-related aggregate in this box, we are going to observe the layer-wise hydration that occurs in such aggregates to study the microstructure behavior, as well as the strength gain the type of strength gain that these aggregates have in them. So this is the heat of hydration test setup that we have in the lab. Along with that, as I said, environmental analysis is one of the major analysis that we are doing as part of this research. So we are going to have certain physical-chemical testing conducted in the lab. And the important ones are obviously the pH testing or the metal leaching that we are going to see. And for that, we are planning to have, we have a lot of samples. We collected samples in the Shelby tubes. We were trying to get to as much depth as we can, collecting samples from even 6 feet deep soil and going on the sides as well to see not only the pH values and the metal leaching of the aggregate themselves, but also the metal leaching and the change in pH that they have in the surrounding to incorporate the overall environmental aspect of using these aggregates. So this was just a brief presentation from my side. I will thank you all. Thank you all. If you have any questions, please let me know.
Perfect. Thank you so much, Qasim. Quick question for you. I was wondering for the long-term hydration process in order to continue in the field, what are the best field conditions that you may look for?
So for the long-term hydration process, we have to see for the hydration process to occur. Obviously, we need the supply of water. May that be in the form of rain, and may that be in the form of capillary action that is coming from the water table. Now, once we look at the hydration process itself, we are looking at the strength gain, the formation of CSH gels, the formation of different gels, CAH gels that increases the durability, that increases the strength of the pavement system. Along with that, the other thing that we have to cater for is once these hydration processes are occurring, there is also a phenomenon that changes the pH of the leachate that is coming from it, and we have to strike a balance between that. Either the strength gain costs us a pH change in the environment, and that is the thing that we are looking through this research, that we have to strike a balance between the environmental risks that are involved and the strength gain through hydration processes that we have in the field. So yeah, these are the parameters that we are looking at.
All right, perfect. Thank you so much, Qasim.
Thank you so much.
We can move now to our next presenter, Jill Italiya. Jill is a computer science student at Preview A&M University. He is conducting life cycle assessment for vehicle electrification and hydrogen fuel cells. A very interesting topic. Jill, floor's yours. Thank you.
Thank you so much. Uh, is my screen visible?
Yes, it is. Go ahead.
Yeah. Good afternoon, everyone. For today's research topic, I'll be presenting life cycle analysis of United States EV charging stations. I'm working under Dr. Raghava Komlapati and Dr. Mannar Mahalakshmi. So let's go to the introduction. So as EV stations and their environmental impacts are discussed, as we'll know that the transition of electric vehicles is gaining momentum globally, driven by the needs of reduce greenhouse gas emissions and our dependency on fossil fuels. Basically, this shift towards the EV adoption has created increased demand for accessible, efficient charging infrastructure. So our research focuses mostly on the environmental effect of this electric vehicle charging stations, because as the demand increases, the more infrastructures are been building, and we were looking towards the carbon footprints of this EV charging stations. The problem description and the objective is the environmental impact of charging infrastructure, as I already mentioned, and especially during the infrastructure expansion phase, and it's been often overlooked. The objective is to decrease the carbon footprint using renewable source of energy and identifying the environmental sustainability approach. So the methodology we are using is the tools we are using. SEMA Pro, it's a life cycle analysis tool which uses LTS. It's a long tail sustainability as a database, and through which we do multiple metric iterations for hundred of years and see what individual components do the emissions to the environment. The first part is about the inventory analysis, basically collecting the data of the raw materials like copper, plastic, steel, water is being used in the creation of the charger and the rest of the components on the EV infrastructure, the energy uses to assemble those things, and the emission across the life cycle of EV charging station. We'll be also considering the re-scenario, because considering the re-scenario will be having some payback to the environment, especially for the material like copper, steel, and plastic, which are usually more pollutant to the environment for their production and everything. So this is the system boundary from the raw material to the product, then product to the transportation, then comes the operation and the maintenance. It requires energy, and then it comes to repurpose. So from starting of the point to the end of the life. And we'll be seeing the environmental impact of climate change, water use, human health, and ecosystem. For this presentation, I'll be showing the water use and the human health as the result. So this is the environmental impact assessment of all the stations with station components which are on the EV infrastructure, and this is a midpoint category evolution with the SEMA Pro. We can see that the human health, the ecosystem resources, climate change, and water use for the individual components. The charger has the highest overall impact across the multiple categories with the significant values in the resource, cost, emissions, and everything, as charger is the main component for the EV charging stations. And when it comes to the type of energy which is being used to run this in infrastructures, so when it comes to wind, solar, natural gas, fossil fuel, and electricity mix, we can see that the wind and the solar has significant lower environmental values, as we know that those are the renewable source of energy, and as compared to the fuel and the natural gas. And wind and solar are notable more sustainable, showing lower impacts on the human health, the ecosystem, the resource use, energy demand, and the greenhouse gas emissions. Let's have a pie chart view for the water use contribution. The largest contribution for the EV infrastructure is due to the electricity mix which we're using from the grid, and the second one is the charger itself. So someone should be questionable like why the charger has the most water emission, as we know that it uses the semiconductor for their um, manufacturing, and it requires very pure form of water. And other notable components include like steel bollard and cable retractor, and minor contribution from the charging adapter, charging cord, and the charging holder. Now it comes to global warming contribution as the human health. Again, the largest contribution is with the charger itself, accounting for 53%, and the over impact followed by electricity mix, which is 26%, the grid energy, and the rest are very negligible. It's like 10%, 3%, and the minor contribution is from the charging adapter for the 2%, and the charging holder. The results and the overall discussion is like environmental impact finding. The research occurs for environmental impact across the life cycle of EV charging station. The key findings are, if we'll be using the renewable source of energy like solar and wind, which significantly reduce the carbon emission compared to the usage of grid power source, because it uses the non-renewable source of energy, coal, and other sources. Then the compound impact, the high carbon emission from material like concrete and copper. Repurposing this material can basically reduce the overall carbon footprint of the EV infrastructure, because the foundation of the EV has been always made with the concrete. And we'll be addressing these problems like the challenges we face, like significant environmental impact from expansion of EV infrastructure. The solution for this emissions are like prioritizing renewable source of energy, basically focusing on more repurposing material, not using plastics and all, and optimizing existing gas stations to make them EV charging stations, so that no one has to build a separate charger infrastructure for the charging. And with the parking lots are always bigger, so they can be used to do the EV charging station. And basically it can be looked toward the environmental concern and aligning with sustainability object and reducing the ecological impact of EV charging station. The future work would be basically emerging charging technologies, so more towards nowadays few countries are focusing on wireless charging. They can just drive on the road and the car will automatically charge. And ultra fast charging stations for enhanced user convenience, and it can be implemented anywhere. Material and innovation and recycling, so more towards using renewable source of energy and more recyclable material to decrease the carbon footprint. And rural and urban optimization, like tailoring infrastructure solutions to rural and urban, basically using parking lots and other open area for the building charging station. Thank you. Any questions for me?
Thank you so much. Interesting presentation. I do have a couple of questions. This topic is very close to my heart. I didn't see any indication of the functional unity you use. I assume you use a charging station as functional unit, and the other, and I want to, I seek your confirmation here. And the other question is, at least for life cycle assessment of materials, we noticed that one of the let's say the most damaging from an environmental pollution point of view stages is transportation of material. I wonder, in your analysis, how transportation is included, transportation of the different components of the charging station, for
Yeah,
example.
so basically we were including the transportation from raw material to the manufacturing. So basically those transportation, and then from manufacturer to the installation site, those transportation. And basically in the United States, all state doesn't produce the same amount of raw materials. So we have considered few of the areas from the states, and we have assumed that this much would be the minimum distance to transport any good from this state to the another state, and every transportation is included under the product of itself.
All right, very good. Thank you so much.
Thank
Excellent
you so much.
presentation. Thanks, Jill.
Thank you.
We are halfway here, and our next presenter is Archee Patel. Archie is a master's student in construction engineering and management at Rutgers University with a civil engineering degree from Nirma University in India. And Archie, floor's yours. Thank you.
Thank you so much. Thank you for the introduction. I'm going to share my screen.
Archie,
you see
again,
it?
yes, we can see it. Archie, again, when you see my face popping up, it means that you have 1 minute remaining in your presentation. Thank you.
So you have to turn on your audio and tell me that I have 1 minute.
All right, we'll do that. No worries.
Okay, thank you. Okay, hi, good afternoon, everyone. My name is Archee Patel, and I'm a grad student at Rutgers. And today I am here to discuss a topic that's gaining more importance in transportation management, which is integration of equity into transportation asset management, or TAM. You might be wondering, and my topic here is to identify the challenges related to embedding equity into TAM. I would like to mention that this is a small area of the research that I'm working for Professor Vasiliki, which is a professor at Rutgers. So you might be wondering why it is so important to identify challenges related to equity in TAM. I'm going to answer that question after the end of my presentation. To give you a roadmap of today's presentation, I'll start with an introduction to equity in TAM, followed by the problem description, research objectives, methodology, and then I'll dive deep into the results and discussion, and then I'll outline some potential future work that we need in this area. Let's start with the introduction. What is equity? So, equity in this context is defined as the consistent and systematic, fair, just, and impartial treatment of all individuals, including underserved communities who have been denied equitable treatment. TAM, which is Transportation Asset Management, plays a central role in managing, operating, and maintaining infrastructure assets across the life cycle. By integrating equity into TAM, uh, state highway agencies can make sure that transportation outcomes are fair and just and impartial. However, there are disparities in access, investment, and resource allocation, which affects communities. This study seeks to understand and analyze the challenges that state highway agencies face while embedding equity in the TAM processes, especially with different regional needs. The problem statement here lies the state highway agencies encounter both practical and policy related obstacles while trying to incorporate equity into TAM practices. This often complicates the process of translating federal equity into real world practices. This study poses the research question: what are the specific challenges that state highway agencies face while incorporating equity into TAM systems? To address this question, we have three primary objectives. I'm going to discuss these objectives through methodology. Our methodology involved a two-part approach. A comprehensive literature review was conducted to establish a baseline understanding, and then a stakeholder committee analysis was conducted for direct insights from different stakeholders. For the literature review, I conducted a comprehensive literature review to understand the documented challenges in TAM. For that, I used specific keywords such as equity, asset management, social equity, and transposition asset management. I focused more on online research articles and government reports. Through this, I found 9 core studies which were related to this topic, and out of those studies, I found 15 different challenges. I then categorized those challenges as per the USDOT Equity Action Plan's 5 pillars. For the stakeholder committee analysis, I analyzed the results provided by the stakeholder committee. The committee included 7 representatives from different backgrounds to reflect a range of perspectives on equity. 4 structured meetings were conducted, and inductive coding was performed out of the meeting minutes. As a result, 20 codes were identified, and then these codes were then categorized under the USDOT Equity Action Plan's 5 pillars. Let's discuss the results. Moving on to our findings. In the literature review, here are the 15 different challenges. Each challenge was then examined for its frequency across different studies. Just to mention that this is just a part of the table and not the whole table, as I couldn't fit the whole table in this. Let's talk about 1 or 2 examples of the challenges that I found through literature. First one is complexity in defining equity. So challenges in defining equity affect how resources will be allocated, which impacts property values and investments in disadvantaged areas. Second one we can say is inclusion and accessibility. It is very important to make sure that policies and technologies are accessible to all segments of the population. Let's discuss the results from the stakeholder committee findings. The blue one are the highlighted ones are the five pillars of USDOT Equity Action Plan, and below are the 20 codes found through the stakeholder committee analysis. Let's talk about 1 or 2 examples in this one. First is let's talk about budget limitations for equity initiatives. This was one of the key challenges raised by the stakeholders, and it was the constraint of limited budgets while implementing equity-focused initiatives. Another major challenge identified was the lack of specialized training and adequate staff capacity to implement equity-based practices. Stakeholders also mentioned that many TAM professionals are skilled in asset management but are not trained in equity-related issues or community engagement. Let's talk about the comparative analysis. This is a significant part of our study. We conducted a cross-reference comparison between the challenges identified in the literature and those noted by the stakeholder. This comparison revealed both commonalities and unique regional challenges. For example, one major challenge highlighted here by both sources is the lack of integrated data systems. Many state highway agencies face struggle with outdated systems and cannot provide the necessary data needed for assessing equity-related outcomes. Imagine trying to make equity driven decisions without the reliable data. This is like driving without map. Another challenge here is variation in regional priorities. While federal guidelines provide a broad framework, each state and region face unique socio-economic factors that define how equity is perceived and addressed. For example, one state highway agency in an urban area may prioritize public transit equity, while a rural state highway agency may focus on equitable access to road maintenance.
Archie, you have 1 minute.
Yeah, thank you. For future work, to continue addressing these challenges, I propose several recommendations. Firstly, enhancing data integration systems. This could improve data accessibility and accuracy for different asset classes. Secondly, developing a targeted training program for TAM staff to help understand and implement equity based decisions. Thirdly, expanding public involvement in this type of strategies would ensure diverse perspectives. As for future research directions, we see potential in broadening the stakeholder engagement beyond New Jersey, as we see that our representatives were mostly from New Jersey State DOT. This can help include representatives from different states' DOTs and provide a more comprehensive and national perspective. Also, exploring the role of AI may offer innovative ways to enhance equity in time. To wrap up, I want to return to my opening question: why is it so important to identify the challenges related to equity into time? So, this study addresses a crucial gap in literature by focusing on the practical difficulties that state highway agencies encounter, especially within the US DOT. As few studies have ventured into this area, it is important to shed light on these issues and propose a possible solution. Thank you for your attention. I'm happy to take any questions if you have.
Thank you, Archie. Interesting presentation. Just a quick question here. When you presented the challenges, if I understand correctly, there are 15 of them. Did you find any study where maybe they mention a challenge that was not mentioned in other studies? So since it was mentioned in one study only, you decided not to consider it? And if you did not consider that challenge, on what basis? Only because it was mentioned in one study only?
Of course. So these are the 15 challenges that I found through literature review. So the highlighted ones in pink color are the ones that were common with the stakeholder analysis. The white ones are the challenges that were not very frequent or analyzed through the stakeholder committee. I can take the example of climate change impacts. Even though this is a very major challenge and has to be studied and analyzed, this is a very different area. This is not what we are looking through as our research project. So this is the challenge that was not so common along it was common, but it was not used in our research.
All right. Very good. Very good. Thank you, Archie. Thanks for the presentation. We can move to the next presenter. And the next presenter is Shanmukha Gonnabathula, sorry. Shanmukha is a PhD student in civil engineering at Texas A&M University. His research focuses on using wicking geotextiles to enhance the resilience and sustainability of highway infrastructure. I guess floor is yours.
Thank you. Let me know if you guys are able to see the screen.
No, we're not seeing the presentation.
Not yet.
Okay.
And we lost you now. We can't see you anymore.
Well, Mike, do we want to go ahead?
Yes, maybe we can move to the next presenter.
Avinash, I can share for you if that works. I have it ready to go.
Okay.
Did he drop off?
I think he might have dropped off.
Yeah.
Oh,
No,
there
he's
he
here.
is.
He's here.
Avinash, I can share it for you if you would like.
Yeah, let me try again.
There it is.
Yes. You're on the sheet. Okay.
Okay, perfect.
Sorry about this. Yeah. Hello, everyone. Today I'm going to present about application of innovative geosynthetics to improve the drainage and resiliency of highway embankments subjected to extreme climatic conditions. This project is a collaboration with 4 universities: Texas A&M, Michigan State, Arizona State, and Prairie View. I'm working as a PhD student in Texas A&M University under Dr. Anand Pupala and with Dr. Puneet Bhaskar. Next. Yeah. Are you guys able to see my screen or?
Yes.
Yes, we can.
Okay. Yeah, this is a brief presentation outline for today, starting with the introduction and background. I'll briefly explain about the problem description and objective, further going into the research tasks and ongoing works and the future works for this project. To start with a brief introduction, highway embankments are often constructed with the locally available soils in many areas, and most of the soils are often considered to be problematic soils, some of which are highly sensitive to the cyclic moisture change and which increase the chance of slope failures. Usually, these problematic soils include expansive soils and frostive soils, which are highly sensitive to the volume change. And with the time restriction for this presentation, today I'm going to talk about expansive soils, in which we can see the cyclic volume change of shrinking and swelling with the cyclic climate change of wetting and drying. So this cyclic volume changes cause cracks in the surface of the slopes, with with these cracks and the moisture intrusion into the slopes aid to the slope failure. This is one of the slope failure observed in Texas area. And since Texas is highly rich with expansive soils, this is one of the frequently occurring problem. Hence, we suggest to remove the timely removal of moisture from soil is very essential for effective and durable performance of any transportation infrastructure, including pavements and embankments. And to provide a brief background on conditions for slope failures, it needs 3 conditions. One is problematic soils, which is expansive soils in this case; environment conditions, which is rain and the dry seasons; and finally the water supply, which increases the pore water pressure and causes the slopes to fail. For this, traditional solutions suggested are soil replacement for the embankments, which is often expensive, and chemical stabilization, which has concerns on sustainability and durability of the soil, and finally, mechanical stabilization of slopes in increasing the friction and the factor of safety of the slopes with geosynthetics. So in this project, we are primarily concerned on the water supply, and we are proposing to use the geosynthetics. In this combination, we provide an alternative solution of use of innovative geosynthetics to increase drainage and shear strength of slopes, including both of its hydraulic and mechanical properties, and in turn increasing the stability and long-term performance of the slopes. To give a brief background on the geosynthetics, geosynthetics usually have multiple of functions, including separation, drainage, filtration, barrier reinforcement, and protection, often used in many highway projects and landfill projects. And out of this, primary focus of this project is the drainage and reinforcement properties. Uh, so in a combination of these two functions, geosynthetics that provide these two combination is often the geocomposite, which is a combination of geogrid and non-woven geotextile, in which the geogrid provides the reinforcement with the interlocking mechanism as shown in the picture, and the non-woven geotextile would provide a drainage and separation functions. However, the non-woven geotextiles are often considered to be very ineffective in unsaturated conditions, as they only perform when the soil is highly saturated for drainage. So, as an alternative, the new type of geotextile was proposed, which is a wicking geotextile. It has reinforcement wraps and wicking wraps. Each wicking geotextile has multiple wicking fibers, which are embedded, uh, which are embedded with numerous wicking wraps, and each wicking wrap contains very micro channels, and these micro channels help it generate a large amount of suction. So to give a background of the wicking geotextile, as I was saying, wicking geotextile consists of very fine hygroscopic and hydrophilic fibers, which generate high suction even in unsaturated conditions, unlike the non-woven geotextiles. And this wicking geotextile is uh, effective in transporting the water from underneath the pavement or the soils or the embankments to the exposed portion of the geotextile in the in-plane direction, as they are very fine grooves. And the working mechanism of the wicking geotextile is shown in the right. Because of the fine channels of the geotextile, it generates a high capillary suction, which aids in collection of soil moisture from either side of the wicking geotextile till the influence range. The collected moisture is then transported to the exposed portion with the generated paths because of the woven paths, and also the potential and RH difference between the inside and the outside of the geotextile. Once the water is reached to the exposed portion, the water evaporates because of the surrounding climatic conditions and the relative humidity. Once as the water evaporates, the geotextile dries out and again starts to create potential difference, starting back the cycle again. And to reiterate the problem statement, we say slopes with expansive soils are highly unstable because of the cyclic moisture variation and excessive moisture intrusion, increasing the pore pressure and decreasing the stability of the slope. And for this project, the research objective is to evaluate the performance of this wicking geotextile in slope applications to provide additional drainage and improving shear strength by removing excess moisture and resulting in overall increasing of slope stability. And for which
Avinash, you have a minute remaining.
yes. For which our research tasks include literature review, a few laboratory testings, and modeling. In the laboratory testing, it starts with the material characterization. As I mentioned earlier, we are doing for expansive soil and also frost heave soil. So all the laboratory tests are done for both the soils. Material characterization, interface friction testing, unsaturated hydraulic properties, shrink shell properties, and large-scale slope simulation. And currently, we are working on the direct shear tests and large shear tests for the both expansive and frosty soils with various moisture contents, primarily focusing on the wet side, which is the problematic case. And all these moisture contents are tested with in the direct shear and the large shear box. For the large shear, we are using a metal block at the bottom to maintain the interface of the geotextile without any deformations. And we are also monitoring it with moisture sensor and water potential sensors as it varies with stress and the drainage time. And for the future works, we are planning to do a large scale model of the slope simulation with geotextiles installed with sensors. And from this, we are expected to obtain observe the performance of the geotextile and obtain the optimum range of the distance and the usage of number of geotextiles in a given slope for the different type of soils. From the obtained data from the direct shear and this slopes test, we are planning to develop a numerical model with coupled analysis of traffic load and drainage. Thank you.
Thanks, Avinash. So, very quick question for you.
Yes.
Are you planning any life cycle cost assessment for these type of applications? Because obviously, if you're adding something in the payment structure, that will be an added cost.
Yes. So in general, we are planning to do the life cycle analysis, but as per the scope of this project, we have not included in this. But in general, we are trying to do it for the making geotextile. Yes.
All right, perfect. Thank you so much. So we have 10 minutes for the last presentation. Um, The last presenter is Sai Sannala. Sai is a master's student in civil engineering at Texas A&M University. Sai, I'm gonna ask you to really be on time so that we have the very last question at the end of your presentation, and then we can move to the next session. Thank you.
Yeah, sure. Thank you. Hi, howdy all. Good afternoon. I need admin help in presenting the slides. Yeah. Today, I'm going to present on the project increasing the lifespan and resilience of the bridge superstructure concrete through the durability-based performance evaluation. This is a small area of research work. I'm working under Dr. Anol Mukhopadhyay. Next slide. Yeah, these are the team members which involved in this project. PI is Anol Mukhopadhyay and John Braley is a co-PI. Nenad Gukansky is a research team member. Praveen Saraswatula and Abhijit Mistry are a research team member. And myself, Sai Manoj Reddy, as a graduate student assistant working on this project. Next slide. So today I'm going to cover the outline of like introduction, what is the problem involved and the methodology, and I'm going to discuss the results and discussion and the future work, and I'm open to the questions. Next slide. So the introduction and the problem statement goes like in USA yesterday, like when opening session, I remember that in USA like 650K of bridges been there, like which has been built like 30-40 years back, which are going currently like a lot of durability issues due to many factors like environmental, physical factor and chemical factor, which causing the safety concerns of the existing bridges and also like maintenance cost because of the premature deterioration and like a lot of rework is being involved. So what is the solution for these issues? Like to predict the service life of the bridge at mixed design stage. Early prediction and the service life is going to prevent and extend the bridge take life and optimizing the investments. So how we are going to do is currently in our research, we have integrated the rapid assessment tools and accelerating testing procedures to understand the degradation of concrete by integrating the at the mixed design stage and predicting the long-term performance of the concrete. Next slide. So these are the key innovations at the material stage. So high performance concrete properties and performance has been predicted using the TTI tool, where rapid prediction of lab-based durability properties been predicted instead of laborious ASTO standards within the shortest duration, and also rapid estimation of in-field service life durability performance being assessed, like chloride ingredation, how the concrete is going to behave through the chloride and freeze-and-thaw conditions. The second part, structural part, is like a deterioration and condition index model, which will be involved by Rutgers, where the structural capacity of the bridge will be assessed through the NDT techniques, and it's going to predict the performance of the bridge by integrating the material properties from the TTI tool and giving the results of extended lifespan of the bridge. Next slide. So here I'm going to talk on literature review and laboratory test program at TTI and application of TTI tool for prediction of concrete bridge mixtures and durability properties and performance. Next slide. So my current role here is like testing the laboratory techniques like including testing planning, scheduling, and mix casting, and laboratory testing, and assessing the data and evaluating and reporting. And the task 5, which consists of like a TTI tool implementation of durability property prediction of bridge mix, where here the results from the laboratory test is going to analyze with respect to the tool, develop the prediction output, and reducing the gap between the results of both laboratory tests and the prediction model. Next slide. So the task 4, like which I have involved, the laboratory test program consists of like 3 phases. In phase 1, like the material collected and material characterization, and the phase 2 is like designing a mixed design stage and testing the fresh and hardened properties of the concrete. The third most important phase is like durability evaluation at the TTI laboratory. Next slide. So material characterization involves like concrete ingredients where cement and aggregate has been tested for their mineral composition and the physical properties like specific gravity, density, and the gradation of size to get the inputs for the laboratory procedures. And also this inputs serves as for the predictive model to bridge the gap between the laboratory properties and the predicted model. Next slide. So the material characterization for the cement is being tested using the quantitative X-ray diffraction studies and XRF testing, where we can see we'll get a clear picture on the mineral composition of the cement material and what properties been influenced for this cement. So same is carried for the material characterization for aggregate. Next slide. Yeah, this is the XRD for the aggregate, where clearly it gives the view of like what type of mineral has been predominant in that this aggregate, how it's going to influence the durability of the concrete through the lifespan of the bridge. Next slide. And the phase 2 here, like we have developed the mixed design and tested for the fresh properties and hardened properties like initial setting time, final setting time, tensile strength, compressive strength, and modulus of elasticity. Next slide. And phase 3 durability evaluation is currently in the progress, where we have casted all the samples and we have started the laboratory test procedure like autogeneous shrinkage, dry shrinkage, and chloride analysis, surface resistivity, bulk resistivity, ASR, and a microscopic evaluation. Next slide. So the main focus of this study is to get the rapid determination of the lab-based properties of the concrete instead of going like laborious ASTM and ASTO test, and getting those inputs of the laboratory test results and integrating with the model, which will assess the performance of the concrete of the bridge deck. Next slide.
You have 1 minute.
Yeah.
Thank you.
So this is the result which with respect to the shrinkage, the lab measured and the tool predicted. The lab measured, where we have collected from the laboratory test procedures for autogeneous and dry shrinkage. On the right side, the tool predicted is being shown. It clearly indicates that autogeneous and dry shrinkage, the autogeneous shrinkage is 324 microstrains, and autogeneous shrinkage is like a 31 microstrains, and dry shrinkage is 324. On the right side, the tool predicted with the user inputs like a basic properties of the material. It's without evaluation of the test in the laboratory, the tool is going to predict microstrains in terms of shrinkage. Next slide. The future work, like the next 6 months plan is for us is like completing lab-based durability evaluation and integrating that lab-based durability evaluation for the model and predicting its properties in terms of service and durability, and also in combining these material level properties with the structural level properties where it's been performed at Rutgers. Thank you. Next slide. Yeah. Thank you for the opportunity.
Thank you so much. Thanks, Sai, for being on time. Very quick question. Do you see at any point artificial intelligence jumping into your research, especially for the predictive models?
That's so interesting question. We are working on that, like machine learning tools, like how to replace the laboratory test procedures with the AI or machine learning so that we can avoid the laborious process of testing procedures. But yeah, it's a definitely a good question. Like it's going to be like futuristic if we able to work.
Perfect, perfect. Thank you so much. So
Thank you.
this was the very last presentation for this session. I want to ask all the presenters to open their cameras together with the judges for the presentations so that we can take a picture of those involved in this session. I'm gonna close my camera here.
We are missing one of the judges, Dr. Jack Zhang.
I'm here.
Can you turn your camera on?
Yes.
Okay.
I already turned on my camera, but looks like you cannot see me.
Okay. Just so you guys know, Dr. Zhang is the UTC Tier 1 Director for the Cybersecurity Center that he's running at University of Houston. And Dr. Judith Mawaklongi is a partner with the Cybersecurity Center that is led by South Carolina. Clemson University. It's one of the 5 national centers that is part of the UTC program funded by the bill.
I was able to get the group photo. Thank you.
Okay, thank you. Appreciate it.
All right, so Stephanie, back to you. Thank you so much, everybody.
Thank you so much. I really appreciate it. That was such an amazing session. All right, so we are going to just move along to our sponsor stakeholder roundtable discussion. If I could go ahead and invite Dr. Melissa Tooley back to the stage to lead us in this discussion. Melissa?
Yes, ma'am. So glad to be back on stage. We're always happy to hear what our students are up to, and I really enjoyed that last session. What we're going to do for this next one is do a roundtable discussion to talk about how our industry stakeholders are involved in our programs. And the UTC program is unique in that education and technology transfer are emphasized as much as research in this program. And key to our success in all 3 of those areas is the involvement of our industry stakeholders. They enhance our research by guiding our program with their input. We give them an opportunity to provide input into our research program, into the research ideas that our PIs give us to consider. They provide necessary matching funds, and they serve as project monitors on our projects as well. They hire our graduates. They provide input into our education and workforce development programs, and they're critical to technology transfer because they adapt our research outputs into practice. We're fortunate to have stakeholders from consulting and the public sector with us today. So with that, if I could ask Melvin Harris, Amy Maki, and Mohammad Bhuiyan to join me. This session is a roundtable session, so I encourage all of our attendees to ask questions in the Q&A tab on the right-hand side of your screen. And I'll go ahead and introduce our panel members, and then we'll start the discussion. Our first panelist is Melvin Harris, who is the Director of Contract Administration at WSB. He leads the development of a top-tier construction inspection team here in Texas. With over a decade of experience, he has managed projects statewide, specializing in highways and bridges within TxDOT. Mr. Harris's leadership has been key to WSB's growth. He's a graduate of Prairie View A&M University with a Bachelor of Science in Civil Engineering, and I have it on very good authority that he is a former student of our director, Judy Perkins. He's committed to mentoring emerging engineers and serving the community, and he drives value for clients in the construction industry. Amy Maki is the founder and president of A.O. Maki and Associates, a consulting firm specializing in human capital development. With over 40 years of experience, she's a sought-after speaker, writer, consultant, and coach. She's held key roles at the University of Washington, Bethel, where she developed policies for student, staff, and faculty services, and at the University of Washington at Seattle, where she focused on student success and diversity. She's worked at San Jose University as a program manager. She's authored several works, including The Journey from Graduate School to the Professorate and Everyone Needs One, Everyone Should Be One, a mentor. She holds a bachelor and master's in education from the University of Washington and certificates from Harvard's Consortium Program on Negotiation. And I don't think our third panelist has been able to join us. Administrators, have we heard anything from Mohammad? Okay, well, I believe that we can have a productive conversation with just the three of us. Melvin, are you still there? There he is. Good.
Dr. Tuli Mohammad is here.
Oh, good.
I just need him to activate his camera and mic.
Okay, all righty. Well, I'm going to go ahead and introduce him then while we are doing that. Okay, Mohammad Bhuiyan has 18 years of experience in geotechnical engineering. His expertise in geotechnical investigations includes shallow and deep foundations, pavements, slope stability analysis, underground utilities, tunneling, and more. He's at the Harris County Flood Control District and has supported numerous public and private projects in Harris County focusing on designing flood mitigation methods. He's also previously worked with the Corps of Engineers and the Bangladesh Army, as well as with the United Nations in Liberia as a Blue Helmet, supporting the rehabilitation of Liberian infrastructure and road communication systems. So as you can see, we have a really diverse panel with a broad range of experience and in what they do and how they're contributing to the transportation profession. So I think while we're working out our technical difficulties with our panel, I think we'll go ahead and get started between me and Melvin Harris. And there's Mohammad Bhuiyan, and Amy's back with us. So can everyone hear me okay?
Yeah,
Yep.
good.
I can.
Yes, thank you.
Wonderful, wonderful. My first question for all of you is, in your opinion, what is the biggest transportation challenge facing us at the local, regional, and national levels? We'll start with you, Melvin.
Oh, okay. So being in here in the Houston region, I think we really get looking at it from, I'd say our local and regional are probably very closely intertwined, right? And they all tie in with what our big national is. And that's the fact that we've got to find a way to get folks in the industry, get them skilled up and get them trained.
Mm-hmm.
Working as a construction manager, I was at an AGC meeting recently and learned that, by 2031, we're going to lose about 41% of our current workforce. And that's from the laborers out in the field all the way through the construction and project managers. So finding folks that are skilled, knowledgeable of what it is that we do. We live here in the Gulf Coast, and we've got some challenges that you don't see across the rest of the country. And also being here in the Houston metro, one of the fastest growing metros, we've got challenges with the development that's coming in, making sure that it's reasonable, responsible development, and making sure that as we develop and grow, we've got access to funding, and we're able to put systems in place to connect communities, keep people moving, and not get to the point where we grow population-wise faster than we can from an infrastructure standpoint. I've got some more notes I can continue to go on, but I'll give Mohammad and Amy a chance to talk before I say all the good stuff.
Well, I think in my
go ahead.
Oh, I think in my particular position where I focus on education, my concern really in the region and nationally is the same as Mohammed's, and that is the workforce. And although we focused a lot at this colloquium on bachelor's and master's PhD programs, I happen to have two daughters who work in the industry. One is actually a tester in the lab for concrete and asphalt. And the other one works in the procurement area for WashDOT. And they have such a shortage of individuals who are not only knowledgeable but have an interest in the field. And I think there's a real shortage of opportunity to educate young people about the opportunities and the growth potential. So in our region, and I happen to live in Arizona right now, but the region doesn't really promote, as I see as a citizen, a lot of the activities from K through 12 community colleges where a lot of skilled professions can be developed. So I think that's, for me, one of the bigger issues, both nationally, regionally.
Yeah, I expected that you might have a few things to say about workforce development based on our previous conversation. Mohammad, what do you have to add?
Yeah, basically, since I work for Harris County, so a lot of roads and bridges in Harris County, they are pretty old and they need to be replaced considering the existing traffic load and the volume. And like a lot of them are city of Houston and Harris County is presently replacing them, but there are more need to be replaced. And another thing is that like some of their foundation systems are really old and need to be replaced really like as fast as possible. And our roads, they're also like some of them are like basic pretty old and distressed. There are a lot of distresses you can observe while driving, like you can see a little bit bumpy. So we need to work on that basically to make a Harris County or the Houston for our better living.
Hey, Melissa, can I jump in real quick? Because I've got a question for Mohammad on this. So, from a construction management standpoint, we saw post-COVID and really just kind of with throughout life cycle of things, materials become less available. You know, I look at things and I'd say regionally as a state, beyond just the Gulf Coast, you know, we're having challenges with accessing asphalt materials and even the concrete during the fly ash shortage. I think that as we look at the way we construct things, we've got to find a way to get it's a little bit more innovative, and the market pushed it. But Mohammed, are you seeing some of the same things over at Flood Control? Just kind of fly ash shortages and different material shortages that are kind of creating some additional need for.
I agree with you. And whenever you will see that there is a shortage, you will see that another indication is that your price will go up.
Yep.
So exactly that's what happening. Everything is like the price before COVID and after COVID. Everything like is way more expensive, like which should not be. Anyway, so that made the construction cost significantly high. So which needs more taxpayers' money. And I really agree with you that yes, there is a material shortage, and for that, like for example, like we use riprap, which is stone, crash stone, but now we have to use actually concrete, like the debris, crash them in the plant and use them as a replacement of crash stone.
Yeah, we're seeing a lot of that in the textile world too, where some of that recycled concrete is being used as riprap and different. There are conversations. There was a long conversation at the Asphalt Pavement Association's annual meeting about using recycled concrete as aggregates. But Melissa,
does that mean that you have to retrain or train individuals who have to test the material on site with these new items that you're using?
No, they had been being used for a long time, but thing is that like so
Okay.
the performance of like the crust stone and concrete may not be the same, but if you have availability, you must use the best material, right? So, but once you don't have like the price is too much or there is availability issue, then probably you can sometimes you might like use a good performance material, but may not be as good as reprap, like crust stone like that. But definitely that has to be like past the testing, all the testings. But that, yes, because
So
it is,
there isn't any need for policy changes or that govern the quality of the product.
no, the
Not,
policy we can use like reprap, crust stone, or concrete.
Yeah.
yeah,
But
I think it's going to be. Sorry for cutting you off,
now
Mohammed.
now you need to like choose like which one is more available or which one is more expensive.
Affordable.
Yes, affordable, depending on the project.
Okay.
Yeah.
Yeah, and one of the things that I've heard in some of my association meetings, because I'm very active in the American Road and Transportation Builders Association, and one of the problems that we've talked a lot about is how much more expensive materials have been and how it's really driving the bid costs for projects through the roof. And while everybody's very, very excited about the opportunities provided by the IIJA, those funds are not going as far really as you might think with the increase in materials, and it's been very difficult. And I think for me, when we talk about what our challenges are at the national level is the continuing deficit in the Highway Trust Fund and what new innovative financial mechanisms we can use to try to make sure that highway funding doesn't dwindle. I mean, the Highway Trust Fund is not sustainable right now. So that I think is my personal opinion of what our biggest overarching thing is, because it all boils down to having the money to address the problems.
Money.
Yeah, that we all feel like we have, the things that we're all dealing with. If I could just kind of change gears just a little bit, I wanted to make sure that we had a chance to capture for our attendees, because this colloquium is people that are involved in insight, all the way from the student to the researcher to the administrative level. So I know one of the things that we'd like to know is what can we do to engage industry in our research and programs? I mean, what types of things do y'all think are most effective in reaching out to what you do from the research community? I mean, what advice do you have for us?
All right, I'll jump in. So I think it's exactly what we're doing right now. Let's reach out. Let's have the conversations. Um, honestly, it's all a large ecosystem, right? We look at universities as the pipeline that feeds the future and the teams that we build going forward. So as an industry, it's our responsibility to make sure that we provide opportunities for the folks that you guys are training and building up, whether it be through internships, coming down for job fairs, partnering up on projects, sponsoring projects, even if it's just a data share and data transfer, come in and bring some of our CAD technicians to come teach ORD or talk about the ways that the industry is moving that and teaching some of those skill sets. But I would also say, again, it's that grass is going to grow where you water it. And so part of it, I think that we could use as an industry from the academic world is, hey, let us know how we can jump in and help. And then let's make sure that we partner together.
I think that's great advice.
And I think that one of the things that I saw with Insight, some of the successes that are already working, like for example, the project at Michigan State, and particularly I was impressed with the highway construction workforce mentoring program, where there was a combination of industry came in, taught, and that produced a workforce. And I think that whole continuum of partnership is just a key for the workforce. And I think that Insight in that particular project was doing really well. And especially, I also enjoyed the activity at Michigan State, where they were actually involved in going to community state fairs, doing things where you just use a drone and pretty soon you have an audience, and that builds a moment of discussion. So as industry, we also can promote those kinds of things. For example, when I'm giving a presentation, I can mention civil engineering, or I can mention community colleges and what opportunities are there that would lead somebody to go into the profession. So I think anytime we have an opportunity to mention it, whether it's inside or some other dialogue that we're having, I think it's just another opportunity.
And I think that like your research teams, they can reach out like Harris County or flood control or City of Houston, the government entity, and arrange some presentations about their research capability, which can actually enhance to realize the problems of the payment. City of Houston, they have a lot of payments within city of Houston. Or flood control, we manage a lot of channels and ponds. Similarly, Harris County, they maintain a lot of pavement, roadway pavement or bridges. So your research team, if they can have some presentation to like the engineering departments of Harris County or flood control or City of Houston, and present them their research capability and to like and basically they can prove their capability that they can find out something which will reduce their construction cost or maintenance cost significantly. Probably those government entity will be interested for funding or like doing joint research with you guys.
Thank you. Well, I think another thing too that we've heard a lot about in the education sector is that, and we see it in our classrooms with our students that, they come to us with different technology skill sets for sure. I mean, they are comfortable with technologies that it might take us a little bit longer to get used to. But my question to y'all is on the receiving end of our graduates when you hire them, what kind of changes have you seen in the workforce in terms of, how they contribute, how they operate within the workforce environment? What kind of skill sets would you like us to encourage in them or provide for them before they graduate? What are your thoughts on workforce?
Well, in my opinion, and I'm not in engineering, but at presentation at other colloquiums and conferences, I find that students lack some of the interpersonal skills. Because we had the COVID period and now so many people are involved in gaming and other things, their interpersonal skills are lacking. And also, I have a concern, and I think there's an opportunity to have sort of an ethics component of maybe the mentoringship program where, and I noticed that in the mentoring program, there is a moment where students are asked to identify their own core values. And I think those kinds of things are critical and will also help motivate that equity in the transportation arena that we were talking about in Insight. So I think it's the soft skills, communication skills, and awareness of ethics.
Yeah, and Amy, you're really uniquely qualified to address that. I mean, what can we do to help our students with interpersonal skills? I mean, a lot of them now were products of the pandemic, and so they didn't get
right.
They missed out on a lot in their high school and early college experience.
Dr. Perkins and I have worked on some of the conferences together where I've done presentation on communication skills. As simple as that might sound, students aren't aware of body language anymore. They aren't familiar with pitch and tone. And so I think there's an opportunity, and I would say maybe in the mentoring program where there's a session where they really get to learn about those interpersonal skills. How to read a room when you go into a classroom as a faculty member. You take a look at the room, or in a business meeting, Mohammad, you go in, Melvin, you go in, and you can pretty quickly, if you're good, assess the audience and who may or may not be the doubters. And I think that's a skill that needs to be taught as well. So it's just when you have an opportunity, and I think in Insight, maybe one of the locations would be, or opportunities would to be incorporate that into the mentoring program.
Yeah. Amy, I feel like everybody needs to have a Dr. Perkins experience. My Dr. Perkins experience, my Dr. Perkins experience comes from being an undergrad and a student in her classroom, right? And she had a
That's
rule.
a scary thought right there.
I've had a Dr. Perkins experience too.
Yeah, and she had a rule, right? She will happily help us with anything, but don't just come to her with a problem or what you can't do. Come with her with a potential solution.
Yeah.
And that mindset that she drilled into me in those 2 semesters, man, that drove me through, honestly, my mindset as a professional. And I feel like that a lot of the young grads that we get, they hear that, they go into a meeting and someone critiques their work or they're reviewing their work, they get red lines back, and it just kills their confidence, kills them completely. And not that everything is huge conflict or anything, but what we're seeing right now is folks are getting those things there, and they're getting their feelings hurt by it. But whereas at the end of the day, we're not questioning your competency. We're questioning how did you get there. We want to make sure that we use these as teaching and training tools whenever we give these assignments. Plus, also, until you have your stamp, a lot of it's also making sure that you're doing things the way that we would. The thought process is there and sound.
Right.
And what I see from a lot of the newer hires that we have is they don't separate the two. It comes through as we're critiquing and attacking them, and not trying to develop and look at their work. They're not separating their work from who they are as a human.
Do you see them being more that way now than they were, say, 10 years ago?
I think a little bit. Just because people aren't. Oh man, I hope I'm not stereotyping too much, but I feel like the kids that graduated pre-COVID for high school, college, they had the opportunity to develop those skills more, those interpersonal skills, because they were forced to be around each other more. And there's been so much of a reduction in interaction interpersonally that I feel those skills get lost there. But yeah, I see this also as a technical side too, right? So from a technical standpoint, if what universities and community colleges are teaching, we've got to make sure we're teaching the same software, same physical skill sets that we're using in industry, and pushing for the same certifications, the same training certs. I had a kid who had he was NICET certified in everything material testing. Well, unfortunately, in a TxDOT space, the regulating testing certificates for us is ASCE or ACI, American Concrete Institute.
Yeah.
And so you got a young person who spent all that time, energy, effort, and money to get certified in what he thought was the relevant material testing certificate, and he ended up being completely wrong. So I think we just need to make sure that we bridge that gap. And again, if we build that ecosystem, we'll know, like ORD, teaching ORD versus Civil 3D. If the intention is to graduate folks that can come out and work on highway projects, we got to make sure we're putting together the right skill set.
That's good advice.
I think that like you should encourage your students to like during the summer, do some internship in any of the in the industries, or like Harris County or flood control. We had a lot of college students during summer for internship, or the previously where I used to work, that was a private consultant. They also had college students during summer for internship. So you can encourage your students to try for those internship, and once they're back, end of the summer, share their knowledge their learning, or like basically the industry experience with other students, make some presentation, and they should share their experience, and they should, by that time they should be able to understand what is their like the weakness or strength. If they think that okay, we need to have this kind of program or these classes, they should like reach out to you guys, so that you can plan or develop new curriculum or enhance your curriculum or the syllabus, whatever.
All right, so Melissa and Amy, I got a question for you guys, pending off of what Mohammed mentioned. So one of the things that I strongly encourage any intern that I ever get the privilege to mentor for a summer is, while you're an undergrad, don't obviously if you're studying civil, try to make sure that your internship opportunities are going to develop within that civil space.
Yes.
But diversify as much of that experience as you can. If you get an opportunity to do a summer at the flood control, a summer at TxDOT, go do a summer with a consultant, a summer with a testing lab. Figure out what it is you're interested in and what it is you're not, because your career is going to be 30 years. Try to figure out what you're interested in early. I mean, do you guys give similar advice or share similar
And
experience?
when I mentor students in whatever discipline, I always advise them to attend different types of seminars, presentations, whether it's in your area of expertise or not, to give them an overview of what components there are, say in civil engineering. It might not be in transportation. You might be interested in structures, whatever it is. I agree with you totally, and I think part of that has to do with, I'm a big fan of mentoring and have developed mentoring programs for NASA and some other organizations. And it's so important to have a mentor within the department so that they can direct you in a diverse areas. And you were lucky to have Dr. Perkins as a mentor who definitely would focus you on a variety of choices and not dictate what was sort of your future. And almost probably, I would guess, demand that you do the research yourself to find out what your real core interest is. But I'm really a strong believer in doing that mentorship, whether it's going to industry, like Mohammad said, that make to come in. So I think you're correct in that. Diverse points of view within a profession.
Yeah, and I'm sorry, please go ahead.
Go ahead.
I totally
No,
agree.
I was just.
Yeah. I totally agree with Mr. Harris that they should come like for internship to the industry, because like they can have an idea what kind of work, depending on their specialties or the degree, what kind of work they're going to perform. Like I remember we hired one student for internship, and in Texas, summer is really brutal. Like he was sent to the field for 3 days, then he decided to quit. So, so the thing is that then if you think that you cannot go for site visit, then probably civil is not a good thing for you. So if they come early, like at the beginning of their undergrad, like either freshman or sophomore, at least they know that okay, this is not my stuff. Probably I need to choose something else, because civil involves a lot of site visit. So that's why they should come as early as possible.
Yeah,
And I think
go ahead.
Good. Well, I was just going to say that like I mentioned, like for my daughter who actually does the asphalt testing and breaking of the concrete, whatever she does, I go and watch her and I'm like amazed. But when they lose an employee, they just recently have another one who came in and found it so fascinating about the materials and the testing that he's going to go back and get a civil engineering degree. So you're right, Dr. Mohammad, that internship or that exposure at whatever level is what I'm trying to say, gives them an opportunity to see what diverse opportunities there are in civil engineering.
Yeah. And I would also encourage them, you're talking about internships at various types of organizations. Don't forget about research internships too, because we've got some of those through Insight, and those can really help attract students into the profession too. And honestly, mentorship, I've found when I get as much out of mentoring a student as, I probably get more out of it from them than they do from me. You learn a lot more about, how they think and how the world they're existing in culturally, because like we've talked about earlier, it is changing. It's changing very, very quickly. But the other thing that I like to encourage students to do is to become a whole person. To explore all those different internship opportunities every summer, learn more about what you want to do in civil engineering, but to also seek out being a well-rounded person. Find something else that you're passionate about outside of your profession, because civil engineering, and I am a civil engineer, honest disclosure, not all of us are. Transportation is very interdisciplinary now. But for civil engineering, I just really feel like being a well-rounded person with a lot of different interests is going to help you to be a better civil engineer. And I think that's probably true for a lot of different professions. Oh, and I see Judy has added a comment to the box here. It says, you may want to mention Insight having project monitors to support our research projects. And that is true. And I know at least one of you is serving as a project monitor. So that reminds me that one of the questions that I did want to ask y'all is, for those of you that are serving as project monitors on Insight projects, can you tell us a little bit about your experience with that? Because I was thinking that Mohammad was a project monitor. I may have been misinformed.
No, I'm not actually. I'm a geotech engineer. Basically, I review the design of Harris County. Project management is a different, like the side they're managed by civil engineer definitely, but I'm a subject matter expert actually.
Oh, okay. Yeah, and that's the kind of activity that we love to have our industry stakeholders do, serve as monitors and advisors for our projects. So actually, that's a requirement for every Insight project that they have a project monitor from industry that is guiding that research project.
Yeah.
And Mohammad is doing that for Dr. Alam at Prairie View, and we're greatly appreciative of that. I really think that that's an element that helps to make sure that our research stays relevant and is addressing the problems that industry needs us to address. So with that, we've just got a few more minutes, but I wanted to give each of you, if there's anything that you wanted to share with our attendees that we haven't already covered, I thought I'd give you just, a couple of minutes to maybe say whatever is on your mind, what problems you think we need to address, what advice you think we need to hear. We'll start with Amy.
I was going to say that as a senior member of this roundtable, there are some issues, like particularly in Tucson, where we have a low light policy because of Kitt Peak, would have a lot of telescopes and everything up there, that I always wonder, for transportation issues and research, if there are new, let's just say this, we have a lot of pedestrian deaths in Tucson. And with AI technology and the new modes of transportation that we're going to have, it concerns me more. Like I just have, and it's just this gut concern about what does that mean for an area like Tucson, low lighting policies, high senior population, and pedestrian death. It just concerns me. That's all. The other interesting thing about road transportation is that the lanes that are being created on highways and freeways are much narrower, I noticed. And does that, and I'm not an engineer, so does that make it faster, but does it make it safer? I I don't know. Those are questions. Just as a citizen, as I'm driving in Seattle, Washington versus Tucson, Seattle, Washington freeways, the lanes are very narrow, and in Tucson they're quite generous, shall we say? So it's just interesting comment.
Duly noted. Thank you. Thank you. Melvin?
Yeah. So, first off, this is very dangerous. Telling me getting some closing thoughts. I'll share. I guess I'll just focus what I've got to say to the students, the folks that are working towards graduation, towards joining industry. Biggest thing I'd say is you have a lifetime to make a career, and the career that you have in mind as a young person is probably going to change 3 or 4 times before you turn 40. And the advice I'd give is stay optimistic, stay eager and curious. That's what makes engineers special. We're very curious. We love solving problems, and throughout the early parts of your career, because man, I remember those rough days studying for the PE, having little ones hollering around, crying while you're trying to work on an RFQ. It's there's going to be challenges, but stay engaged, stay very, very optimistic, because an industry as a whole, it's very rewarding when you see a project that you have built come together, and you see the way that it impacts the community. Mohammad, you mentioned you had a summer hire quit. I had one quit in the middle of a soil nail wall placement down on Project Braze at Braze on Braze Bayou down at what was that, Brazewood in Maine, in downtown, or in the medical center. And I had to pick up, leave my wife and kids, and go out to that pour in the middle of the afternoon. And it was one of the most humbling things, because it reminded me of why I fell in love with the job I've got now. And while we're putting that in, you see folks riding their bikes around and commuting. It's like, man, this people truly use this project. So it just adds that sense of pride back. And there's a million different avenues a civil engineering undergraduate career, a master's degree can take you. The career can drive you many different ways. Just remember the excitement you had when you started undergrad and why you chose that, and keep it throughout.
And Melissa, can I just say one thing too? If we're addressing the students, and I think a key point throughout your career, whether it's in your undergraduate, grad, or in industry, is the importance of having a mentor and identifying those people that can give you that pat on the back when you need it, or the slap on the back of the head when you need it.
Yeah.
And so I think the key thing that I would like to leave for the students is find yourself mentors, more than one, to meet the many needs that you are going to face throughout your life as well as your career. So.
Absolutely. Absolutely.
That's perfect.
Well, and we'll give Mohammad a chance to share his thoughts, and then we'll wrap up.
Yeah, basically, I always say my daughter that if you want to pursue something, some program, try to find out if you like it or not. So same thing for the students. If they want to be an engineer, they need to find out really they want to be an engineer or not, or are they good at engineering or not. Like basically, they need to find out their interest. They should not be engineer because their mom wants that, their dad wants that, and by any chance, if they become engineer under pressure, then they'll be a bad engineer. So people should self-motivate it and find out what is their interest.
All right. Well, if I could ask everybody to provide a round of applause for our roundtable participants. I know one of the admins. There we go. All right. Thank you very much, Melvin, Amy, and Mohammad, for joining us this afternoon to share your thoughts.
Thank you.
And we really appreciate it. And with that, I'll go ahead and toss it back to Stephanie.
Yes, thank you guys so much for that insightful conversation. I'm going to go ahead and pass the baton over to Dr. Judy Perkins to give us our closing remarks. Judy, it's all you.
Thank you. Thank you very much. I know we've already did that round of applause, but Stephanie, send it out one more time so that everyone knows they've done a job well done. So in closing, thank you for joining us. I hope that you agree that this was an impactful, inspiring, and productive 2024 NCIT Virtual Colloquium. I am extremely proud to serve as the NCIT Director. Just so you know, the Colloquium is an annual event for NCIT, and we will rotate the host of this event to another partner come 2025. That host will be Rutgers University. In my open remarks, I did mention that we would be in communication with you following the event. So we do have a colloquium survey that will be sent out in the next coming days. We will also share with you the winners of the UTC Quiz Bowl, the first, second, and third place winners from the undergraduate and graduate presentation sessions. And also this information will be placed on our website. We will send you invitations to join us on January the 6th in Washington, D.C. We plan to have two events. One will be a technology transfer student poster event, followed by our reception in the Washington, D.C. area, particularly the Texas A&M University Bush School. Now, NCIT will recognize our organizers, presenters, which include faculty, researchers, students, and speakers and support team during the January 6th event in Washington, D.C. In case you're not able to attend, we will make sure that you do receive your token of appreciation. With that being said, Godspeed, and in advance, I wish everyone a wonderful Thanksgiving holiday. Stephanie?
All right. Well, that is going to conclude the NCIT Colloquium. We thank you guys for joining us today. If you have any questions, you can still leave them in the chat now. We will be downloading these to share with our presenters that if you had any. So thank you so much for joining us, and we will see you in the future for future events. Y'all have a good one.